All right. So as I said before I hit recording, we are going to finish up section 2.1, and then we're going to dive into section 2.2. The only part of section 2.2 I don't love is the stem and leaf plots. And I usually create the stem and leaf plot ahead of time so I can just quickly put it in my, write it on there. But for some reason, I didn't do that today. So we're going to do the best we can. So stem and leaf plots, and I'm going to give you the disclaimer. It is my least favorite part of the representing with graphs, but it is something we need, and it will not be on the test, but I believe that there is a question or two about stem and leaf plots in the homework. So I will be teaching you about that. And we're going to be talking about shape of distribution. Shape of distribution is something that continues with us all along throughout the entire class. So it does become important, but it's not too hard to remember. So let us go. Oh, and finally, I'm going to end with the lab. I'm going to end going over the lab. Okay. So this data right here represents the marital status in millions of residents 18 years or older in 96 or 1990 and 2006. I just squished those two dates together. We're going to do a side-by-side relative frequency bar graph. So side-by-side graphs are really cool because it helps you to compare things. And I'm not going to require you to make one, but I know that there's been quite a few people who've used them in final projects. And I think that in the homework, there may be one or two of them that you need to, that you will need to like interpret or whatever. But so here are our marital statuses. And so relative frequency, this is a reminder, we did this yesterday. So in order to calculate a relative frequency, we take the number like 40.4, and then you would divide it by the total number. So all of those numbers added up together. You do 40.4 divided by that to get the relative frequency. So I'm not going to do that right here. We did that yesterday, Tuesday, whatever. So I'm not going to do that here, but that's just a reminder. So the reason, I'm going to go back again, sorry. The reason we would do relative frequency is because the totals here are not the same. If the totals are not the same, then we're comparing apples to oranges by saying, oh, there's 40,000 or 40 million people never married. There's 55 million people never married. We can't really tell how much it increased, really, because we don't know what the total number is. So we do relative frequency, so we're comparing percent to percent or proportion to proportion. So now I am going to actually look at the graph. So take a look here. And you can see that the light blue is 1990 and the dark blue is 2006. And it's really easy to see here that, okay, never married, a higher proportion of people were never married in 2006. There's fewer people married in 2006. Fewer percent of the people were widowed and more have been divorced. So it's really easy to see and compare those. And if you want to, you can look here and say, okay, so it looks like 2006, approximately 10% were divorced, and approximately, I don't know, looks like maybe 8% were divorced in 1990. And you can kind of look at the numbers with the frequencies or the relative frequencies. Got to sneeze, I feel it. Maybe. I wish I had a light to look at. Sorry about that. All right. So this is a side-by-side bar graph, and they're pretty useful when you're comparing two different populations. So one population is people in 1990, and then the other population would be people in 2006. And it's probably people 18 or over, or Americans 18 and over. That's probably like the technical way. All right. So pie charts. Pie charts are fun to look at, and I know that people like to use them a lot. Like you see them on the news all the time. You see them in advertisements. Sometimes they can be misleading, and they're really easy to make misleading. I mean, some of the ones that are like 3D and like tilted and things like that, they do that on purpose to try to mislead you. Or if you don't label the parts of the pie graph with percents or numbers, it's really easy to just kind of say, oh, look, that one is twice as much when it could be not. So I like pie charts because they're pretty, but in general, I don't use them a lot. So it is a circle, and each sector of the circle represents a category. The area of the sector is proportional to the frequency of the category. So you'd have 25% of the pie chart shaded like red or whatever, if 25% of your data is represented by whatever that one is. So let's take a look. So we're going to look at just 2006 and look at just the frequency of married, never married, widowed, etc. of the marital status. So let's take a look. So here is a pie chart. This one is definitely not misleading because you can see pretty clearly, and it's labeled with your percents, and we have a good key. So make sure that if you are creating a pie chart, that you're making a good key, that you have it labeled with the percents, and it's just nice and pretty. Now, I want to show you, I'll show you just because it's fun when we do the lab, how I can make that pie chart a little bit misleading. And hopefully it'll kind of give you an idea. I will never require you to make a pie chart by hand. A lot of times we will use those. If we did one by hand, we would use a protractor. We would use a compass to make a nice circle. I am not going to do that to you. You will make one with Excel, but you will not make one with by hand. Any questions about pie charts? Okay. I think we've all seen enough of these that you're like, yeah, I kind of get a pie chart. I kind of get them. Okay. This is some raw data. Remember, raw data is data that has not been cooked. This represents the number of available cars in a household based on a random sample of 50 households. We're going to create a frequency and relative frequency distribution. So remember, the frequency is how many times a certain number shows up. So we would look at how many times, how many zeros are there here, and then that would be the frequency of zeros. The relative frequency is the proportion of the total that value is. So let's take a look. So my frequency here, there were 4 showed up 0 times, and I had a total of 50 data values, and 4 of them were 0. So I did 4 divided by 50, and I got 8%. So 8% of people have 0 cars. And then I just keep doing that all the way down. 26% of people had 13 cars, and on and on and on. So we make that nice relative frequency. And in my opinion, relative frequency is much more meaningful than just frequency, because I can look at the percents or the proportions. I can look and see, okay, so only 0.02% or 2% of people have 5 cars. Clearly that is an unusual value. I'm going to talk later, probably next week, about what constitutes an unusual value. Questions on frequency, relative frequency? This is kind of review, but making sure we're there. One thing that comes up in the homework, and I didn't realize until a couple of terms ago that it was something that was confusing to people. So I'm going to put a 3rd row over here. This shows up a little bit in the homework, and so I'm just going to do this. Make another row. So some of you have already looked at the homework. You might have seen this cumulative frequency. All this means is that they add up the percents as they go along. So this would be 0.08, and then I would take that 0.08 and add it to 0.26. So I'd have 0.34, and then we add the 0.44 to the 0.34, so 0.78, and so on and so on. So all it is it's cumulative, so that down here would be 100% or 1.00, and I'm just adding them up as I go along. That way I can look at this. Just a second here, 0.92, 0.98. So I can see if I look here, 92% of all of them have 3 or fewer cars because I'm adding them up as I go along. That's what cumulative frequency means. So you may or may not have encountered that. And I mean, some of you might be like, oh yeah, I figured that out, but it's not really, because we didn't talk about it in class. Some people are taken aback when they see it. So I thought I would just throw that out there for you. All right. Question about cumulative? All right. Moving on, histograms. This is kind of what we were talking about before the recording came on. So histograms are similar to bar graphs. Now, I think we'll have some examples that are discrete, but most of the time histograms are used with continuous data. However, you can use it with discrete, but most of the time histograms will be continuous. That's usually when I use it. I'll usually do a bar graph if it's discrete and a histogram if it's continuous, but I'm pretty sure one of our examples has it for discrete. Sorry about that. So just like with a bar graph, the height of each frequency or relative frequency the height of each rectangle is the frequency or relative frequency. We draw rectangles. These are words that you're going to see here, class or category of the data. The width of each rectangle is the same and the rectangles touch each other. That's the difference. This right here is the difference. That's a beautiful star that I have there. This is the difference right here between a histogram and a bar graph. Our rectangles here are going to touch each other. Well, give you a second. And I know that seems like a real minor difference, but statisticians get really up in arms if you mix up a bar graph and a histogram. I don't know why, but it is a thing. So histograms touch each other and bar graphs do not. And part of the reason that they do is because if our data is continuous, it would make sense to flow from one bar to the next because there are not gaps between the two data values. It would just flow from one to the next one. All right, moving on. So once again, we're going to look at the number of cars. Yes, I'm going to do a histogram with something that's discrete, but as I said, sometimes we do, but in general, histograms will be continuous. So here I have my frequencies and my relative frequencies, and we're going to draw a nice, pretty histogram. Okay, here's my histogram for the number of cars in the household. So notice a couple of things. My bars touch each other. They're all the same width and they touch each other. So only with discrete are the numbers in the middle of the bars. Notice here how these numbers right here are in the middle of the bars. You only do this with discrete. I'm going to write this down. The x-axis, axis labels in the middle of the bars, the middle of the bars, only with discrete data. It's because that whole bar is 0. That whole bar is 1. The whole bar is 2. It's not a range of values. It is the whole bar is 2. That's why we can put it in the middle, is because we're representing the whole bar and there's no range of values because I'm not going to have 0.78 cars. I mean, my son-in-law might because he continuously works on cars and there's always several of them in disrepair around his yard. So I'm thinking that probably right now he has about 3.63 cars on his property because everything's always missing pieces. All right. So I think that we get to do continuous. I think we're going there. It's weird how I will like work on a PowerPoint like an hour before class and then I just forget. Okay, let's move on. So this one is relative frequency. So it looks exactly the same and pretty much identical, but we have the relative frequency instead, the proportion over here instead. Just make sure that whichever one you choose to make, that you label it correctly, whether it's relative frequency or frequency. All right. So that we're easing our way towards our continuous data. So classes or bins, because Excel uses the word bin instead of classes. And so I tend to go back and forth between bins and classes. They are the categories into which our data is grouped. So when we have a large number of different discrete data values, or if we have continuous, we create classes that contain intervals of number. So it might go from 0 to 4, and the other one would go from 5 to 9, and the other would go to 10 to 14. So if we had a lot of different values, or if we had continuous, we will use classes or bins, and they will be in intervals. And all of these intervals will be the same size. Right. So this data represents the number of people who are currently worked as disabled. And so notice how I split my data from 25 to 34, 35 to 44, 45 to 54, and 55 to 64. Notice that they are all the same width. So the same number of values in between. We always make our bins or our classes the same width. The lower class limit is the smallest value within the class. So this right here would be my lower class limit. Man, that's ugly, sorry. This would be my lower class limit right there. The upper class limit is the largest value within the class. So this right here is my upper class limit. So my first category, my first class there has a lower class limit of 25 and an upper class limit of 34. So the class width, we take the two consecutive lower class limits and we subtract them. So I could take 35 minus 25, and my class width, or my bin width, is 10. And all of this will make a difference when we are making our histograms in Excel. I can't remember. I don't believe I ever make you draw a histogram by hand. I can't remember. I don't think I do. I think that your homework might, and I think they might make you do one kind of by hand in the homework, but I don't think I ever make you do one by hand. Try to remember, but I don't think it happens. When we're in person, I make people do them by hand. I'm mean like that. I keep telling my students at the high school I'm mean, but they don't believe me most of the time. All right, moving on. So here's a lot of data right here. You are not going to be, well, I think I'm going to use this for stem and leaf plot, but currently we're going to make a histogram with it. So this is the time between eruptions in the Old Faithful Geyser in Wyoming. Took a sample of 45 eruptions, and we're going to create a frequency and relative frequency distribution tables. And then we're going to create some lovely histograms. Right. So the smallest data value is 672, and the largest data value is 738. So when I'm choosing what to put as my lower class limit, usually I think they say convenient number. I say pretty number. I find a pretty number that's right below my lowest value, or if my lowest value is already a pretty number. 670 is much prettier than 672. So I'm going to make my lower class limit 670 of my lowest class. My class widths are going to be 10. So you just pick a nice, I think they call them convenient numbers, something like that. You pick a nice, pretty number, like right below your lowest value, and then you determine how wide you want your class width. We're going to do 10s. So here I have my 10 class width. You keep doing classes until your highest value is within a class. Yes.
About the width.
So
you're saying you can choose any even number, technically.
Well, you could choose any width. I could have made my width 8 if I wanted to.
Okay.
made my width 7 if I wanted to. It doesn't matter. It's
Just as long as it's consistent.
yes, exactly. As
Okay.
long as every single one. And I'm going to show you the difference. I think I choose a class width of 5 and make another histogram, and I'll show you why you would choose one rather than the other. And so much of it is just personal preference and making it visually appealing.
Gotcha.
Yeah.
Thank you.
No, that was a really good question. I just decided to make it 10 because I liked the number 10. So I decided, hey, let's do 10. It generally, I can't remember what my PowerPoint says. I usually say have at least 5 to 12. I think it might say like 8 to 20, but I think 5 to 12 classes is a really good amount. You don't want too many because then it's super messy, and you don't want too few because then the data is not that meaningful. So we want a decent number. We want something to be, once again, visually appealing and useful. That's kind of what we're looking for here, because it's a lot of it's about style, as much as I hate to say it, because I'm not artistic whatsoever. All right. So here's my relative frequency in my frequency table. Notice I do have one bin with nothing in it. That's okay. It happens. But having just one bin with nothing in it's not that big of a deal. And let me show you what my histogram looks like. Whoop. What is this? Let's do that in a second. Hold on. I did a second one with a class width of 5. Take a look at this. I have 3 in a row with 0 in it. As a histogram, that's not going to be very pretty. So generally, you don't want it to look something like this. This is okay because there's just 1 in a row, or just 1 with none in it. This one has 3 in a row. So think about what that histogram is going to look like. And you don't have to think too hard because I'm going to show you.
So in order to make it pretty and not have this zeros, you would want to raise the width.
Yes,
Okay.
exactly. So you just adjust it. You're like, okay, I don't like the look of that. It has all those zeros in there and it's kind of messy. So I'm going to make my width bigger. And it's really personal taste. However, if I notice that you only do 2 bins in your histogram on your lab, I might mark you down a point, because 2 bins is useless. And if I saw you had 30 bins, I might mark you down. But in general, if you stay 5 to 12-ish, you're going to be good. So, I mean, if it's extreme one way or the other, I might take a point off, but I'm pretty lenient with it. And I might give you a comment and say, hey, you might want to drop down a few bins, but then not mark you anything off, because I'm really all about being constructive, because we're working towards making you good at what you do. All right, let's move on. Okay, first, as this says, they say convenient number. We already talked about this. Choose a convenient number slightly lower than the smallest data. So they're going to give you some advice here that I don't agree with. Just letting you know, you're more than welcome to use the next slide's advice, but I don't agree with it. I'm just letting you know, this is what the textbook says. So the textbook tells you to decide how many classes do you want, rather than determining what class width you want. So you can decide, I would like to have 8 classes. So they say to take your largest data value, subtract your smallest data value, and divide by, let's say 8, if I want 8 classes, and it will give you a class width. That doesn't make a pretty class width. I know I've used that word pretty a lot. It's going to be awkward because most of the time, if you do something like this, you will end up with something like, okay, my class width is going to be 7.68 because that's what I ended up with, getting the number of classes I want. You're going to be more successful choosing your class width rather than deciding I want this number of classes, if that makes sense. But if you want to do it this way, you're more than welcome to. You're not going to be marked down. It just doesn't make as much sense to me. So you can try it and see what you think. All right. Okay, so I don't know why I didn't, hold on. Here's the time between eruptions. I don't know why it's out of order. I thought I fixed it. I guess I must have not saved it. So here's the 10 seconds that we did when we had 10 seconds as our interval. So we do have this one empty spot right here, but all in all, it's not visually unappealing. I mean, I'd probably put pretty colors on it, but otherwise it's not too bad. Take a look at 5 as our class width. It's messy and there's the big empty spots in the middle. I think that thought there were 3 spots in the middle. I don't know. We're just gonna carry on, but it's not as visually appealing. This one to me looks much better. It's still useful and it looks better. This one has way too many gaps and it's just all over the place. Now, if this is what you want, that's fine. If that's what you're looking for, if you find this more useful for whatever purpose you're using it for, go for it. Or if you're trying to mislead your audience for whatever reason, I don't know. But
Could you manipulate this graph or either one of those graphs? Well, I guess they're the same numbers
they are the
to
same.
get rid of the gap. The histogram, they should all be touching, right?
Yes, technically, but there's a 0 there. I mean, you might be okay if you did like maybe 12 is your width or 15 is your width. I don't know. I would have to play with it to see what in order to do that. And you're more than welcome to do that if you just don't want the gap. But if you have, I mean, sometimes you're gonna have a gap regardless. Be like, okay, so the only way to get rid of the gap is to only have 3 bars on my histogram. That's not practical. But feel free, manipulate it, decide, okay, I'm going to change my bin width to 12 instead and see if it works or whatever you need to do if you don't like it. Because I mean, I don't like the gap either, but it's okay. I'm not going to like be like, oh man, that is ugly. I'm going to mark you down minus 25 points. So yeah, I mean, if you want to do that, that's fine. Because there is a spot on Excel where you can change your bin width and it'll change the graph and you can decide if you like it or not. All right, I'm going to go back to this spot here. So suppose you're considering investing in a Roth IRA and you collected this data right here. I got this off of page 79 in I think this is from the textbook the school gives you. I'm not sure, but I believe this is in all the textbooks. It represents a 5-year rate of return in different and simple, it's a large blended mutual fund. So I'm going to construct a frequency distribution of the data. I don't know why I can't talk today. I have no idea why. I swear I'm better than this. So here's my table. What I did was made my bin width 8 or made it 1 basically, because 9 to minus 8 is 1. Yes, there are some more zeros here. There are 2 zeros there. And as I said before, if you want to change that, I don't know, maybe 1.5 would have worked. I don't think I tried it any other value, but maybe you like a different value, but I chose to use 1 as my bin width. Let me see, let's get back there. So this is what Excel does. And I didn't put titles on here because I was kind of in a hurry. I created this in Excel myself. I didn't just take the graph out of the book, and I didn't put titles on there, which you'd get marked down for this. So I just marked myself down 2 points. But Excel will just grab your lowest number and will choose its own bin widths for you. I'm going to show you ways to trick Excel. But basically it will always start with the lowest value. It doesn't choose pretty numbers, and that's okay. It just is what it is. But this, if you decided to do larger bin widths and do like 1.5, you can try that and see if it makes it prettier. But I just wanted to show you one with decimals. And also, I think it's changed now, but generally, and I'm going to go back and show you again, generally, we do not put both values on the bottom of our bins. We don't put both values there. I'm going to show you on the other one that we just did here. Notice how we only, what was that?
Would that other graph have been continuous?
This is continuous, yes.
Okay,
Yes.
thank you.
You're welcome. So take a look here. Notice how they only have the upper limits here. They only have the upper class limits here. Are these the lower class limits? These are the upper class limits, aren't they? They're supposed to be the upper class limits. They only have the lower class limits. I just lied to you. My goodness, I am batting zero tonight. They only put the lower class limits there. So basically you're saying this one starts at 690 and goes all the way up until this one starts at 700. It's because it's continuous. I don't need to say that this ends at 699. It just goes all the way up until it hits the next one. So we only put, I'm gonna write it down here, only put lower class limits. And notice how they're not centered. They are at the lower edge of the next bin. So this right here, this 700 goes to this bin right there. So you only put the lowest class limits. They're not in the center. We only put them in the center for discrete. We put that at the lower bin. And this is going to help you for reading histograms in your homework. You'll see that that one right there is the lower class limit. And Excel does what Excel wants. And there's ways to manipulate Excel, but I'm not going to get super crazy on making Excel be extra pretty. I think there's a video, there might be a video about manipulating Excel. I can't remember. I might have deleted it. I'll have to look. All right. Let's go. Let's go to stem and leaf plots. As I said before, these are my least favorite. You'll see as we do stem and leaf plots. Sorry, I got to get my data up here because I'm going to need data. So I'm going to need, this is one of the reasons I use my other computer. There we go. Okay, so stem and leaf plots, they have, so it looks something like this. This would be broken up. So we put digits to the left of this line right here. That would be the stem. So for 147, I would put 14 right there. And then the ones place will be your leaf, and I would put that over here. So this is how we build a stem and leaf plot. And I'm going to show you specifically how we build it. I'm not going to use all of the data we have because that would take me forever to write it all down. But I'm going to show you with a snippet of the data how we can build a stem and leaf plot. And hopefully it'll make sense. But these are my least favorite because I don't find them super useful. Maybe you like them. There's some people really like them. And if you do, that's great. It's just not my favorite. I know it's weird that I have a favorite graph. So when we have a decimal, the stem would be the integer portion and the leaf would be the decimal portion. So I will show you that also after we do the geyser stuff. I will show you what it looks like with a decimal. So let's take a look at the geyser eruptions. So first, I'm going to put the data down raw, and then I'm going to organize it in the way that the stem and leaf plot should look like in the end. So the reason there are 272s here is because sometimes when we have like a lot of values that would be in one leaf, we'll split it into two leaves. So this would be like, this right here would be like 720 to 724. And then this one would be 725 to 729. We do that when we have like a lot of values that are in that thing, then we'll split it. It's not necessary, but sometimes the leaf would end up like way out there and people just don't want that. They think it's ugly, so they don't do that. So I'm just going to put some of the data. I'm not going to do all of it because there's 45 and that just seems like an awful lot. So I'm just going to put some of it, and this is completely raw. I'm just grabbing these numbers off of the raw data that I have. So let me just do a little bit of that. 722, 708, whoops, that would go here. 714, 13, 26, 16, So this is just raw. I have not put it the way it's supposed to be yet. So this is the ugly stuff. 72, 711. Let me put, I want one, at least one in here. Put two of them in there. I'm just grabbing a few now so that I can make sure that I get some in like every spot. Are there any 680s? There are no 680s. And I think we're good enough. So this is just the data that I'm going to grab. I don't want to grab all 45. Okay, so this is not the way it's supposed to look in the end. It's completely unorganized. When we draw a stem and leaf plot, I'm going to rewrite this, 67, 68, 69, 70, 71, 72. I'm going to do another 72s, 73. Even if one of the values, one of the spots, like here's 68, doesn't have anything in it, in order to just count by the same things, we'll still put a spot there, just leave it empty. So the way that we organize these is you put them in numerical order. And even if there's repeats, you will just list it twice. So for example, here I put 2 and 8. Here I'm going to put 5, 5 and 9, 3 and 8, 1, 3, 4, 6, 9, 2, 3, 6, 8, 0, 5, and 6. So this would be what the stem and leaf plot should look like. They're in order, the leaves are in order from smallest to largest. And then okay, I can put that back on. Yes, Holly.
So
Right.
when you're looking at your data, it's
Uh-huh.
saying a bunch of numbers, and the numbers are listed like 672,
Uh-huh,
678,
correct.
680, 695
Except we have
twice.
no 680. There's nothing in this box.
Okay,
There's no 680s at all.
so at the bottom it would be 730,
Mhm.
but there's absolutely no 600 and nothing, 80 doesn't exist.
Right, there's no 680. There's not 680 anything.
Okay, thank you.
You're welcome. And so, yeah, we have 730, 735, 736. Usually there is a key along with it that'll look something like this. Let 67/2 represent 672 seconds between eruptions. There's usually a key of some sort like that, so you can kind of see this is what's being represented in my graph. And so this is, and a lot of times, so you can kind of see the shape of distribution here and things like that. So this is just kind of organizing your raw data, but you still see every data value. And you will have a couple questions on your homework about this, but I'm not gonna have you do these on the homework. I don't think it's on the quiz, a quiz either. No, it's not. I just remember I graded a quiz today. So there's not on the quiz. So this is just something that just for those couple of homework assignments. And stem and leaf plots are things, some people really like them and use them a lot. They're just not something I found super useful. But then again, I'm a teacher, I'm not a scientist or an engineer or anything else like that. I'm not working with Old Faithful. So I'm sure that there's some really good use for it. I just haven't found really good use for it. Any other questions about stem and leaf? I'm going to show you the decimal one in a second. Okay, let me see here. I've got to go back to the data for the decimal. Hold on here. I'm sure I have it. Okay.
I guess, sorry, I have a quick question
Yes.
about the stem and leaf. Like, I guess I am confused. Like, what is this showing us exactly? Like,
It is just showing us all of our data.
okay.
So I mean, obviously this is not all 45 values, but I can see here 695 shows up twice in my data.
Mm-hmm.
I have a 711. I have a 713. I have a 714. I mean, that's really all it's showing me. It's just showing me every data value and it's just organized in a way that it's easy for me to see. Okay, so there are 3 different values in the 730s. And that's really,
Gotcha.
yeah,
Okay.
that's really all it's showing us.
Okay, I thought I was maybe missing something. Thank
No,
you.
you're missing absolutely nothing.
Okay, thanks.
So it will not hurt
So-
my feelings at all if you're like, I don't see the point. It's okay.
Okay, so if you're saying that there are 2 695s,
Mhm.
then if there were like, which I think there are 2 of the 699s,
Okay, yeah, there would be another.
means you didn't count everything, but technically
Yeah.
that would be a 5599.
Yes. Or like,
Because
let's
you gotta
say,
put
let's say that there were,
Every,
I mean, there aren't any, but I mean, if I had 5, 6, 7, 28s, it would look like that. You put every single data value.
okay,
Is that what you're
Okay.
asking?
yeah,
Okay, yes.
okay.
And it's just really a way to represent all the data values. And, I mean, I guess it's kind of a frequency thing because you can see, all right, so in 710s, I have 5 data values. And it's okay if you're looking at this going, I really don't see the point of this. It's okay. Or maybe you do, maybe you think, oh, this is really great. I think I'm going to use this. That's fine also. But don't be thinking like, am I supposed to find this interesting or useful? It's okay if you don't, because I mean, I love histograms. I see them as really useful. And there's something we see every day in the media. We see histograms everywhere. We see bar graphs everywhere. Pie charts, we see them everywhere. This is just something we really don't see. And so it's very weird to us because we don't really see it. And I'm sure that there's a good use for it. And I should probably Google it, but I kind of lose interest, and I'm sorry, and I think everybody probably teaches something that they're like, but most of the stuff about this class, I absolutely love. This is just not one of them. Anybody, any other questions about this? Now, I'm going to really quickly, though, make up, was somebody asking, sorry. Okay. I'm going to really quickly make up some, I don't think I have anything with I do, here it is. So see right here, I have, what is it? I'm going to look on my thing. Well, hold on. I need to find this data so that I can use it. So right here, we have the unemployment rate in all 50 states. And so notice that it's a decimal. So we have a whole number and then a decimal. So if I was going to represent this in a stem and leaf plot, this is disorganized. Here's organized. So then I would probably make a key that says and you can pick any value you want. So there's no rhyme or reason to which value you choose. So I'm going to say let 6.4 represent a 6.4% unemployment rate. So this is just letting people know, hey, there's a decimal there, and all of these numbers follow that pattern. So I have 5 times, I have 5.3% unemployment rate. So this is how we would do a decimal. I don't believe you can really do if we had 2 decimals, and maybe you could do 6.5 on the left and then do the 8 on the other side. I don't know, but I've never seen it done. So that is stem and leaf plots. And I'm going to leave stem and leaf plots in the dust at this moment. I see somebody in the chat. Sorry, let me go open that up. What page are we on? Where are we getting the raw data? The raw data was back here for this. It's in the slides. That's where I got the raw data. Yes, it's in the 2.2 slides. I guess I'm sorry. Did I miss telling you guys we switched to 2.2? I'm so sorry. I'm going back now because I'm like, usually I'm so good about that, about saying, if you're paying attention. Now I have to check. No, I didn't. I'm so sorry. Normally I'm so good about saying, no, it's not in the textbook. Usually I'm so good about saying, hey, we're now entering this section. And I didn't do that. I apologize. Note to self, fix that in my slideshow. And thank you. Thank you.
No,
Petra.
no, you did say we were entering 2.2 because I only watched the 2.1, and when you said 2.2, I thought I should have watched the 2.2 as
Oh,
well.
okay.
So you did say it.
I did. Okay. Thank you. I'm like, wait, I'm usually so good at that. I don't know. I'm just I think the reason I'm feeling off today is because I did testing all day at the high school. So I didn't do any actual teaching. So it's like, usually I'm warmed up for you guys. I've already been teaching all day. So I'm usually warmed up. And I think that that was my problem. Sorry, it's good. Thank you for asking the question though, Holly. I'm sure somebody else was wondering like, where did those numbers come from? So good. All right. So this is the last piece. Let me see. We only have a few more slides
I have
left.
a question real quick.
Yes, of course.
This is Lonnie.
Okay.
So when you're saying that to put down let 6/4 represent whatever,
Uh-huh.
where are we putting that?
You just write it near your graph. You're not going to have to create a stem and leaf plot as far as I know. But if you decide you like stem
Okay.
and leaf plots and wanted to use one, you need to have a key. So I would create it and then
Mhm.
just somewhere near my stem and leaf plot, I would write this or type this.
Okay,
This is just your key saying, this is how you read my stem and leaf plot. Because this alone,
Okay.
you're going to look at this and be like, okay, those are great numbers, but what are they? What do they mean?
right.
So it's
Okay.
key.
But I
Yeah.
wasn't sure if it was supposed to be a part of the title,
No,
because
good.
that's kind of a long explanation for it. So, okay, but a key, that makes sense.
Yes, thank you. That was a great question. Okay. Now we're going to do, so just so you know, this part right here, we will be referencing it a lot, but understanding the shape of the distribution is super important. You're going to be using it quite a bit. We're going to be using the word skew so much this term that when you start using skewers at your next fondue party, you're going to be like, that word skew again. Sorry, I'm weird. Okay, so we're going to talk about the shape of distributions. So you're going to be able to look at a histogram and tell the shape. And right now it's not going to be super useful, but it will be useful later, but we need to be able to understand them. So here we go. So this right here is called uniform distribution. So uniform distribution it's one of the symmetric, it's pretty symmetric, which means that if I drew a line down the middle and I folded it on that line, it's going to line up pretty good on itself. It's usually shaped pretty rectangle. However, as I've stated before, statisticians don't deal in absolutes. So it's possible one of my little bars could be slightly higher than the other, something like this. And then maybe another one is slightly lower. But if it's pretty close to uniform, we'll just say it's mostly uniform or approximately uniform, or one of those other adverbs, we would state that it's basically uniform. So if it looks pretty much like a rectangle, that's a uniform distribution. Next, we have a bell shape. This is our favorite. You may not know to love it now, but you will grow to love the bell shape distribution. It is also called normal, which will come in handy later. It is also another symmetric one. Uh-oh. If I drew a line down the middle, sorry about that. If I drew a line down the middle, I could pretty much fold it in half and it would mostly line up on top of each other. And notice that it is not perfectly symmetric and it's not a perfect bell, but it looks nice. If I draw a line over it or draw a curve over it, it's pretty bell shaped. It looks like I could just pick it up and go ding-a-ling-a-ling. So it is bell shaped. This is the beautiful one. This is the one we strive for and we love. And it is one of the symmetric distributions, but bell-shaped is the words I'm looking for here. Nice and pretty. Okay, this is exactly the opposite of what you would think it is. This is skewed right or right skewed. We talk about which way it's skewed by where the tail is. So I have the tail on the right, it tapers off to the right, so it is skewed right. And this is definitely not symmetric. I have this tail off to the right. So that is a right skew. Okay, I know that you can never guess what left skew is going to look like. Skewed left, my tail is to the left. So if the tail is to the left, it's left skewed. If the tail is to the right, it is right skewed. There we go. And some of these things, I have some great mnemonic devices to remember them, but I just think about where the tail is, look for the tail. So if it's tapering off to the left, it is skewed left. Right, we're gonna take a look at some examples and see if we can figure out the skews. We only have 4 more slides, and then we're gonna take a deep breath and we'll do the lab, and then we're done. So we really don't have a whole lot of time, a ton of time left. So if you've hung in there this far, good job. All right, let's take a look. The first one, think about what the shape of this distribution is. There's not really a tail one side or the other. And if I draw something nice over it, this looks like a nice bell-shaped distribution. Nice and pretty. If it makes you happy looking at it, it's probably bell-shaped. This one right here, kind of like this one, and it's kind of cool, but it is right skewed because it has the tail off to the right. So if you were thinking right skewed, pat yourself on the back, you did a great job. Next, this one right here. This one is left skewed, tail to the left. Once again, if you got that, pat yourself on the back. Great job. You are doing fantastic. I love seeing pats on the back. All right, final one. And the terrible thing about the final one is I forgot to delete the title. Oh, I did delete the title. Yay! This one looks like a rectangle. This one is uniform. This one is uniform. This one's a perfect rectangle. I need to make one that's not perfect so you can see it's still basically uniform. But this one is uniform distribution. So if you got all 4 of those right, you should be proud of yourself. That was the last slide. You all hung in there. So before we go to the lab, do we have any questions on today's material before we go to the lab? All right, I'm going to go to the lab if I can find it. Here's the lab. So there are lab instructions here, but for some reason, I mean, it's kind of a wall of words, and I actually have not, see here. Yeah, so I mean, the written instructions are all well and good, but the written instructions also say to find 50 elements. You don't have to find 50. You need 12 of each. And we are looking for, or 12, 20. I don't know where my 12 came from. 20 categorical, 20 continuous, and 20 discrete. Don't go, I mean, and if you want to have one time, only poll your friends one time, this is not the time to do it. Save polling your friends for when you do your final project, and just do something easy. So I will show you my easy data, and you're more than welcome to copy me as much as you need to. So here, I'm going to do categorical first. My categorical data is 20 of my friends. I don't have 20 here though, for some reason. It looks like I lost Brown. Did I lose Brown? No. For some reason, I don't have 20 here. We're going to pretend I have 20 here because for some reason I don't. So we're going to pretend I had 20 friends on Facebook and I asked them their favorite color. And this is just the raw data. Make sure you put your raw data here. And your first box up here should tell me what your variable is. My variable is favorite color. So I have my 20 friends. And what I did over here is I organized my data. See if I can make it a little bit bigger. I organized my data as a frequency table. So each of my, oh, see, purple's not here. P-U-R-P-L-E. I put one there. I don't know what happened to purple. Is it only one? How many purples do I have? 1, 2, I lied, 3. 3 purples. Okay. Okay. So you count up each thing and put how many of each one you have here. Make your frequency table right here. We are going to use this to make our graph. Before I make my graph, though, where I'm going to talk about these, talk about the boxes here. What is your population? So you need to figure out what your population is. My population was my friends on Facebook. Now, it's not colors. It is not my friends' colors. It's just my friends. I am studying my friends. What variable am I studying? This is where you talk about your variable. I'm studying my friend's favorite colors. I don't care why you're interested. You're probably not interested. You do not need to answer that question. Tell me what your variable is, but you don't, unless you really are interested and you want to share it, you do not need to tell me why you're interested. But yes, tell me what variable you're studying. What are the units? Most likely your categorical data will not have units. I would just type in there no units because it's just color. I mean, if you put the word color in there, I probably won't mark you down, but there aren't units. Units are things like feet, miles, ounces, things like that. But there are no units for color, so I would probably type in no units. Letter D is where you are going to describe how you know that your data is categorical. I would jump back to the definition of categorical and use that information to tell me why yours is categorical. Lastly, where did you get your data? So I want you to talk about, I asked my friends on Facebook, I went to a website. If you went to a website, post the URL there. I stood in front of my closet and looked at 20 shirts or 20 articles of clothing and wrote down the color, whatever it is. Just tell me how you got your data. All right, let's make our pie graph. I need to move this bar that I have on my thing. Give me a second here. They have this funny bar at the top of my screen that I need to move. All right.
What about the question that asks how well your sample represents your population?
So I really don't care about that because we didn't really talk about that. Now, I don't even worry about it. Don't worry about that question. Just tell me where you got your data. I was going to go into it and I was like, nah, just tell me where you got your data. Well, I'm not going to go into that right now. I would rather talk about that later. So just tell me where you got your data. I need to update this seriously. All right. Let's place a pie chart. I don't know if any of you have done a pie chart before or charts in Excel. Excel is super user-friendly. It is the most user-friendly of any of the spreadsheet programs I've used because I've learned that Google does not really like math. Most of Google's products are not super math friendly. And I don't know why. You'd think that they would because math is cool and important, but it just is what it is. All right. So I'm going to highlight all of my frequency table, not the X and the F. I just highlighted all of this. And then you click on insert. And the nice thing is if you go to recommended charts, Excel's pretty smart. It told me to choose a pie graph. If I don't want to use recommended charts, there's all these little pictures here. And this is a picture of a pie graph. And I can choose the picture of the pie graph, but I'm just going to do this right here. I'm going to make this bigger. Okay. All right. So I'm going to tell you from experience that if you want to choose these styles, choose this before you make any other changes, because as soon as you change to a new style, it'll undo every change you've done. So I'm going to go here and I'm going to choose a style. And I would like you to have percents on your pie graph, because this isn't super meaningful like this. Because I can look and see, okay, so the green and the blue look like these two look like they're kind of close, but I can't tell how close. I want percents on your pie graph. Now this one right here has them in black if you like that. There's this one right here. I can choose this. This is kind of pretty. You can add chart elements. So if I wanted to add titles and weird stuff like that, I could do that. I want you to play with it and get one that you like. But I do want to show you. This is 3D one here. I'm going to show you that we don't like the 3D one, but I can't find how to do the 3D one because I don't like the 3D one. All right. So take a
Are we
look.
doing pie charts on all three of the?
No, we're only doing pie charts for categorical. So take a look here. So doesn't this make red and this one right here and this one right here look like super huge? This is misleading. When we have the 3D one, it's almost misleading. And then this one's kind of weird too. Take a look at the donut. I mean, it's not terrible, but it's also not super beautiful. So I'm going to go back to that one. And
That donut chart should not be considered as a pie chart. That's
I agree. It's a donut. It's not a pie.
not a pie. No, yeah.
Because if I want pie, I want pie. I don't want a donut.
Yeah.
It's the pie that my sister ate the center out of. And
There you
nobody wants
go.
it anymore, so
There you go.
There you go.
it's
All
weird.
right.
All the
So,
filling's done.
all right. So take a look at my pie chart, my pie graph. Well, first thing I'm going to do is I'm going to change my chart title because chart title is not a chart title. So friends, favorite colors. You always have to have a title. So the thing that bothers me right now is brown is purple, blue is red, green is this kind of teal color. That's annoying. So let me see here. I'm going to double click on my pie, and then I'm going to go over here. There is a way to do this. Okay. Fill. I'm going to change my colors. So this blue one here, this blue one right here is green. So I'm going to change that to green. Okay. This green one right here. Wait, what is it supposed to be? Did I just do the wrong one? Okay. This one right here is red. So I'm going to change that to red. This one is brown. So I'm going to change that to brown. I mean, if you decide, if you really like to have the wrong colors there and it doesn't bother you, I mean, I might cringe when I look at your pie chart, but I'm not going to mark you down for it. So there I changed my colors to actually match the colors that they are. So there's all sorts of things you can do. I want you to play with Excel. I want you to play around with it a little bit. Your final project is going to have a lot of Excel pieces to it. Plus, if you are using stats in real life or creating graphs or whatever, more than likely you're going to be using Excel. Most companies have Excel on their computers. And the nice thing is Excel and PowerPoint work very well together, transferring the information from Excel to PowerPoint or Excel to Word. They all talk really well to each other. All right. So now that I've done talking about the virtues of Excel, we are now going to go to our next type of data. We're going to go to continuous. On continuous, we're going to be doing histograms because histograms are cool. All right. So once again, there's going to be things I'm not going to require for you to do because Excel has updated their ability to do it. And I apologize for not updating my lab also, but it is what it is. So what I did was I took, this is magnitude of earthquakes. I took the largest earthquake in 50, I did 50, or actually I did so many different countries. I did too many, but in a whole bunch of countries, I found the highest magnitude earthquake, and that is my continuous data. And my population would be countries of the world. And the variable I'm studying is the magnitude of earthquakes. And why am I interested? Because earthquakes are interesting, but you do not need to tell me why you're interested because you most likely are not interested. You most likely found convenient data. Most continuous data will react to a print. Okay. Most continuous data will have units. The magnitude on the Richter scale, for some reason, does not have units. But most continuous data will have units, ounces, inches, centimeters, whatever, right in your units. How do I know it's continuous? Once again, go back to the definition of continuous and use that to describe your why you think this is continuous. Where did you get your data? Once again, I don't care if don't have to explain. Did you notice that explain is spelled wrong there? Man, that's terrible. Sorry. How you got your data. So we're going to create a histogram. What I do want you to type out what your interval width is here, You do not have to fill out this table right here. Because previously, we used to have to create a bar graph and then manipulate the bar graph to turn it into a histogram. And this table was useful for that. Which, I mean, you could still do that if you want, but it's a lot of work. But Excel now makes pretty nice histograms that they didn't before. So that table is unnecessary. You do not have to do that table. All right, let's make a histogram. So I'm going to highlight all of my data, and I have a ton of it. I'm gonna keep highlighting. Let's say though that I'm really lazy and I know I have 140 data values, but I don't want to highlight them all. I'm highlighting down to 86. So I'm going to insert, I'm going to show you how to fix it. Insert recommended. It has histogram right on its list, or you can go down here and choose a nice pretty histogram, which I'm going to do. Okay. So the thing is, remember, I didn't highlight everything. I'm going to show you how to fix that in a second. Okay. I'm going to make my histogram go in its box. So see how it says select data? This says it went to 86. I'm going to change it to 140 because that's where my stuff went to. And that's going to change it because this went from A4 to A140. So now it's all there. So look what it did to my data. It will choose your bin widths, and it will just decide what the widths are. It will decide how many bins you have. It'll decide all of that for you. If you decide just to leave it with what it has, I want you to look and say, okay, my bin width here is whatever 5.15 minus 4.4. I probably could do that in my head, but so my bin width would be 0.64. I don't like the bin width 0.64.
You don't want both of those numbers are at the bottom, do you?
But
You want,
with Excel, we just leave it there.
oh, okay.
If you were making one by hand, you would not leave it there, but Excel does what Excel wants. It's-
Okay. And then on the, if you did do it by hand, you would put the number on the left side.
I would put 4.4 or see, 4.4 would be down on the bottom on the left, and then 5.15 would be right there. And then 5.9. So you'd put the lower limit on the left side. Yes.
Okay.
Okay. So the things I'm missing on my histogram, I don't have a chart title, but I can type that in right here. Largest magnitude quakes per country. Okay. So, and then I want vertical and horizontal axis titles. I need those. If you go up here to add chart element, I want axis titles. I want a primary horizontal. I want axis title. I want a primary vertical. Then you just type in what you want. So here it's magnitude. Up here. Okay, if I can make it do it. Up here, it is frequency. There we go. So now I have axis titles. You can make these bigger. You can make them smaller. You can do all sorts of fun, crazy things. It is 100% up to you what you want to do. See, I made those bigger. You make yours your own. Okay. And then chart design. I might want my color palette to be different. And oh, that's ugly. Let's not do that. Let's use purples because purple is pretty. It doesn't matter. You do you. You can change the color of your titles, whatever you want to do. All right. The thing that I'm concerned about is I don't like my bin width. I don't like it. I like pretty numbers. So what I'm going to do is I'm going to double click on, I double clicked on the area, on this purple area here, and this pops up here. I can have an auto bin width if I want, or I can create my own, which I'm going to do. My bin width is going to be 0.5 because I like 0.5. So the way I did that, once again, I double clicked on the red or on the purple. That's not red, that's purple. I double clicked on my bars and then this popped up. So now I have this nice 0.5. So I'm gonna show you this, and this is kind of cheating, but everything that I've Googled tells me that this is the only way to make my bin go to, if I wanted my bin to start at 4, I'd have to cheat it and actually change my lowest value to a 4. That's the only way that I can do it. And then usually if I do that, I'll like put a 4.4 over there to remind myself that my lowest value is actually a 4.4 and not a 4. That's just if I want my histogram to be pretty. That's if I want these numbers to be nice. And I just, so that if I'm doing any other calculations with it, after I copy and paste this histogram into my PowerPoint, then I would just change this back to do other math to it. But this just makes it pretty. Because, I mean, how many times have I said pretty tonight? We are all about the pretty. All right. Yeah, that's it for histograms, unless you have questions on the continuous.
Do you want us to, when we find out what we're doing for that one, do you want us to do the points like the 5.3, or can they be whole numbers?
What do you mean? Like make it pretty like I did?
No, like you have a lot of decimals.
Yeah.
Do you want us to find something with decimals, or can we
No,
just do?
you don't have to. You could
Okay.
do, I mean, it doesn't have to be decimals. It just has to be continuous. As long
Okay,
as it's continuous, you're fine. I mean, if you were doing like height of length of babies at birth, like find 20 babies. I mean, you're gonna have that baby was, 24 inches long. You're not gonna have 24.36 inches long. But that's still continuous, right?
yeah.
So as
Okay.
long as it's continuous, that's all that matters.
Okay,
Anyone else have a question before we get to discrete? Discrete's gonna take 2 minutes, maybe longer, but because I talk a lot. All right, let's go to continuous. Or discrete, sorry. Let's go to discrete. So my discrete is completely imaginative, except for I do know someone with 6 children, so I did put her in here. So it's the number of children of my imaginary friends. So that is discrete. It is something countable. So what I would like you to do with discrete is I want you to choose your own graph. This is a part for you to just get creative and just create a graph that you think displays your data well. So experiment, and even if you decide, hey, I want to do a pie graph or I want to do a histogram, that's fine. Whatever you want to do is fine, or bar graph or whatever. I just want you to play with the graphs. I want you to use the insert and play with these graphs and just pick one that that goes well with your data. So this is your chance to get a little creative and have fun with it. And as always, talk about what your population is. My population would be Facebook friends. And then what is the variable? Of course, once again, I don't care why you're interested. If there's units, I want units. Go back to the definition of discrete. Tell me why your variable is discrete. And where did you get your data? That's it for the lab. And then there's a spot to upload it. And there's instructions on how to upload it in that assignment. For questions?
Could you explain again what the units are?
So for example, let's say that I did annual rainfall in Josephine County, because that's where I'm sitting. Then my units would be inches. Let's say that I was doing amount of coffee consumed per day, then maybe my units are ounces. So it's just like that, or it's like distance traveled to work per day. My units could be miles. So just whatever the units are. Does that make sense?
Yeah.
All right. Any other questions while we are on recording, while we are currently recording? Okay, I'm going to unrecord. I'm going to unrecord, stop recording.